All right, these are the expected value notes. Sometimes they'll say things like fair game when they're talking about expected value. So you can also put that there. But on the ACT, they're going to use the word expected value. And the expected value is the amount that is expected to be yielded from a certain probability. So, for example, if we look at example 1, a group of 2,000 raffle tickets, so that's important. The frequency, and they just passed them out. They didn't charge anything because that's going to be important in our next question. Okay, shows the number of winning tickets for each prize. Find the expected value of each ticket. And I kind of wrote this down because I didn't want to have to do the math again. So if I look at this, my expected value, there were 100 tickets. So if I look at this one, there were 100 tickets out of 2,000. So that reduces to 1/20th. So you have a 1 in 20 probability of winning that. Okay, and then I look at this one. I have a 50 out of 2,000 chance of winning this. So 50 out of 2,000 is 1/40th. Okay, and I'm just doing basic probabilities. This is 15 out of 2,000, which reduces to 3/400ths. And you can put these on your calculator. I'm just doing probabilities. This one is 5 out of 2,000, which is 1/400th. I've already kind of typed these ones in. And then my last one is 1 out of 2,000. Okay, so those are my probabilities. What an expected value is you're actually going to take each probability, so 1/20th, you have 1/20th of a chance to win $10. So you're going to multiply those together. Plus, you have a 1/40th of a chance of winning $25 because they just passed these tickets out. They didn't charge for them. Okay, you have a 3/400th of a chance to win $50. You have a 1/400th of a chance to win 100. Oh, I didn't leave enough room. Plus, you have a 1/2000th of a chance to win 250. So what you're going to do is you're just going to type that into your calculator, and it's going to give you an answer. It comes out as 188, and I'm just rounding it 2 places because that is your expected value. So what that expected value means is if you were to play this game, all the 2,000 people that play, they're expected to win $1.88. Okay, so everybody's expected to win $1.88. And if you look at your prizes, $1.88 isn't even one of the prizes. So what it is taking all of the winnings and divided by the 2,000. So if this was like a fundraiser and you were charging $1 for the tickets, that would be really stupid because you would be losing 88 cents on every ticket you'd sold. So it's not even a fundraiser, you're losing money. Or if you were charging $2 a ticket, we did that earlier today. And if it's a fundraiser, you're trying to make money. And if you're charging $2 a ticket, that means you're only making 12 cents a ticket on 2,000 tickets. You're only making $240. So that's where they use, I just want you to understand where you use expected value. You would use it in things with probability to see, like some kids in our class suggested we charge $10 per ticket because then you were making, if you charge $10 a ticket, let me put that in, I can't remember what the answer was. So you would be making $9.12 per ticket. So if it was a fundraiser, that would make you $18,000, which makes a huge difference. So you kind of have to think about that. Okay. Now in the next one, this is a raffle where the tickets are actually sold. So one ticket wins $100, but if you look, the prize is only $99 because you have to take away the ticket, like you paid $1, so you only won $99. The next one you paid $10, or you paid $1 and you only won $10, so that's why this is $9. And then you win $5. And then if you look at this last one, we had some discussions about this. This last one is all the losers. So all the losers are actually giving their money away. So when I do this, I'm going to take the probabilities. So 0.0025 times 99 plus 0.0125 times the prize plus 0.025 times 4. And then you also have to do 0.96 times a -1. Okay, so 96% of the people are actually going to lose $1. Okay, so when you look at this thing, when you do this out, it has a negative expected value, which means that the people running this are making the money, because expected value is from the mindset of the players. So the players are expected to win the players are expected to lose 50 cents per ticket, which means the people running it are going to be making 50 cents per ticket. So it always is from the view of the person playing the game. Okay. All right. So if I look at the next one, these tickets are sold for $5 each. And so you have one ticket win. So 1 out of 500. 1 out of 500 wins 1,000, but they paid $5. So they only won 995. Plus 10 tickets. Sorry, I don't have these reduced. So I'm just going to do 10 out of 500. They win, two tickets win 500. And so that would be $495 because you pay 5. And then 10 tickets win 50. So that is 50. Now you have to put all the losers. So wouldn't that be, there's 13 that won, which means 400, because it's 500 tickets. 487 tickets lose. So that's a -5. So I would type that in my calculator. Okay, and when you're done, you get 0. So what this 0 means is this is what's considered a fair game, because there's no winners, there's no losers. Okay, so that is what's considered a fair game. All right, so if you go to the next page, suppose you were given one of 30 free tickets, so I don't have to subtract anything. Suppose at the end, 3 tickets were drawn without replacement. So that means that order matters. Like the first person is going to win. So the first person is going to win $100. But now there's only 29 tickets left, right? So the second person only has a 1 in 29 chance of winning $50. And the third person only has a 1 in 28 chance of winning $30. Now, I don't have to do the negative one that I did up here, because this is free tickets, so nobody's losing any money. So you're going to plug this into your calculator, and you get $6.13. So this is your expected winnings, $6.13. Now the ACT isn't going to ask this part. If your neighbor offered to buy it, what is a fair price? So fair price means that everybody breaks even. So wouldn't my answer be $6.13? Because then everybody breaks even. So that is a fair price for this thing. Okay. All right. If you look at the next one, a company believes it has a 40% chance of being successful on bidding a contract that would yield, so that makes $30,000. So they have a 40% chance of making this much money. But it costs this much to prepare the bid, which means if they don't get the bid, 60%, they're going to lose the bid. So they're going to lose $5,000 50% of the time. So what is the expected gain or loss for the company? So I would do 0.4 times 30,000 plus 0.6 times 5,000, negative 5,000. Oh, crap. I'm sorry. I'm going to have to do this in steps because I don't have the math on this. This is 12,000 and this is 3,000. So when I put that together, it's 9,000. So what is the expected gain for the company? It's a $9,000 gain. So this would be something they would be making money on for the most part. If they get it, they're definitely making money. Okay, so same thing here. A game consists of a single card from a standard deck of 52 cards. The player receives $40 for a heart. If the cost of a draw is $15. So there are 13 hearts in the deck. It's a fourth of the deck. So if you looked at it that way, that's fine. Let's just start with this. A player receives $40 for a heart. So they have a 1 in 4 chance of drawing a heart. They get to win $40, but they're losing 15. So they're really only winning 25. Okay, they get $50 for an ace. Oops. $50 for an ace. So there are 4 aces in the deck, right? So 4 out of 52, that's a 1 in 13 chance of getting an ace, but they're losing $15 because that's how much it costs to play. So that's $35. But $90 for the ace of hearts. So then we need to talk about this. So $90 for the ace of hearts. So that's 1 card. Okay. Because I'm going to have to fix some of these because I should have read it all first. And that's what happens to Mrs. Williams today. So 75. Okay. So let's go back to this one. So if I look at the purple one, they receive $40 for a heart, but they're not going to get anything for the ace of hearts. So isn't that going to be 12? Because that's going to take away. So the ace of hearts is in this one. So isn't this going to be 12 out of 52 cards that are going to win them that, right? And then isn't this one you're not going to get paid for the ace of hearts. So isn't that going to be 3 out of 52? And then that's 1 out of 52. But I also need to take into account the losers. So 12, 15, 16. So 52 minus 16 is 36. So I'd have 36 out of 52 times. You're losing $15. Okay, so I'm going to have to do these separately because I did not bring my phone in here. And I maybe am sorry about it, but I'm not because I'm just trying to get this done. Okay, and then 3 divided by 52 times 35. So this one is, because I could have just typed this all into a calculator. 1, 2, and then 1 divided by 52 is 75. So that is 1.44. And then 36 divided by 52 is a negative 10.38. So I'm going to take, of course I'm going to get it wrong, plus 2. Okay, I cannot do math today. So it comes out as a negative 1.15. So should someone play the game? Probably not, because they are expected to lose money on this game. It's not the best game because they're expected to lose money.